Before running your first experiment in OmniCTRL, you must calibrate the sensor for each of your meters to get accurate readings. The calibration menu in the OmniCTRL software allows you to calibrate oxygen sensors for Witrox instruments, but the VTV sensors should be calibrated following the instructions that came with these and their VTV meter. Instructions on how to do this can be found in the OmniCTRL quick guides. Before entering the calibration menu, your Witrox must be connected in the devices menu first. Note that we are running in demo mode, so the Witrox data you see here is not true data. You must also make sure to have your oxygen sensors connected to an oxygen channel on the Witrox, and the temperature probe should be connected to the temperature channel as well. Upon entering the calibration menu, you will find your Witrox instruments displayed in tabs at the top and their respective phase, amplitude, oxygen, and temperature real-time data graphs showed in subtabs underneath. Each oxygen channel is represented in the legend panel on the right, and the value here is the real-time value read by the Witrox, or the value that you have your cursor placed on. The little settings icon here we will get to in a second. But first, some notes about the parameters in the subtabs. The phase value is the raw oxygen sensor signal from the optote, and the unit is phase angle. It basically measures the phase shift in the blue light from the instrument caused by fluorescence at the sensor die. At 100% air saturation, a new sensor will give a phase value of approximately 28. Near 0% air saturation, the phase value will be approximately 58. The amplitude value is the signal strength, or quality, for the oxygen sensor, so this value can be used as a proxy for the performance of the sensor. Over time and use, the fluorescent sensor die can bleach, which can be seen as a drop in the amplitude value. If the amplitude value becomes too low, it will affect the accuracy and stability of the oxygen readings. Strong UV light can bleach the oxygen sensor die, so keep the sensor out of the sunlight and store the sensor in a dark place between uses. At amplitude values of below 3000, you should replace the sensor to ensure proper accuracy. Note that changes in the ambient light conditions during measurements can affect the oxygen readings, even if the oxygen sensor has a black optical insulation top layer. So avoid direct fluorescent lighting in the lab. The oxygen graph shows the real-time oxygen value read by the Witrox. But the value you see here is dependent on the calibration settings, so if you haven't performed a 2-point calibration, you might see some strange data. We will get to the actual calibration in a moment, but first some details about this last temperature tab. Fluorescence or luminescence-based oxygen sensors are very temperature sensitive. So it is important to compensate the oxygen data according to the sample temperature during calibration and measurements. The temperature values in the legend panel shows the real-time temperature read by the PT1000 temperature probe, here in red, and it shows the temperature value associated with each oxygen channel. Currently, all the values are the same, and if we open the settings menu for either of the channels, we find that the input is set to Witrox. So each channel uses the Witrox's real-time temperature reading. But if we change the input to fixed and type in a different value, the temperature graph will now show this value for the given oxygen channel. Using a fixed temperature value can be useful in some situations, but only if you're able to control and maintain the sample temperature within plus minus 0.25 degrees Celsius, as larger fluctuations can change the oxygen reading by several %. Now for the 2-point calibration in water. When you want to calibrate an oxygen sensor connected to a specific oxygen channel, open the oxygen channel's settings menu in either the phase, amplitude, or oxygen tab. Start by selecting the temperature input. Choose Witrox if you're using the Witrox's temperature probe, which we will assume we are doing here. Otherwise, choose fixed and enter the temperature value below. You can copy this choice to the other 3 channels using this button here. Now place the temperature probe in a mixed air equilibrated water sample. This water sample can be achieved by purging atmospheric air into the water sample using an air pump. Then place the oxygen probe into the same water sample. If you're using a sensor spot mounted inside a chamber, then submerge or fill the chamber with the 100% sample water, making sure that the light from the external fiber cable is always reaching the backside of the sensor spot. Otherwise, the Witrox cannot read the oxygen values. Now wait for the phase value to stabilize around 27 to 30, and then click Copy Current Values to save the current values as the high calibration value at 100% air saturation. OmniCTRL will now transfer the temperature input value and the phase reading into these 2 fields. Now transfer the oxygen sensor to an oxygen-free water sample. For example, by purging nitrogen gas into the water sample, or by dissolving around 10 grams of sodium sulfide into 500 milliliters of distilled water. Wait for the phase reading to stabilize around 57 to 60, and then click Copy Current Values to save the current sensor signals as the low calibration values at a 0% air saturation. Click OK. And that's it. You have now performed a 2-point calibration of your oxygen sensor. Repeat this procedure for all remaining sensors. The calibration data is automatically saved internally in OmniCTRL and will remain the same until you change them or reset the software settings. Go back to the main menu. Your Witrox and oxygen sensors are now ready to use in an experiment. A quick note about how often you should calibrate. You should typically perform a new 2-point calibration of oxygen sensors when the value is off by a few percent when measuring at 100% air saturation. And usually, you only need to perform the calibration at 100% air saturation, since the point at 0% air saturation has little to no drift. As an example, if you're measuring in an air equilibrated water sample, which you know is supposed to be 100% air saturation, and you measure less than 98% or more than 102%, it's time for a new 2-point calibration. You should always calibrate before using a new oxygen sensor. The PT1000 temperature probe for the Witrox instrument is a factory calibrated RTD sensor that cannot and should not be calibrated. If you're using other Loligo software like Witrox View 2, then please notice that the calibration data are not shared between other software. So you still have to do a calibration of each oxygen sensor in OmniCTRL, even if you have calibrated the same sensor in Witrox View. And that's it on how to calibrate your device sensors in OmniCTRL. Next, we will look at how to perform the pH to CO2 conversion required when using pH meters.